If you ask someone to draw a World War II fighter plane from memory, they'd probably draw something like this, with a big propeller at the front, an engine behind the propeller, and the cockpit behind the engine. And that was usually the case. Mustang, Spitfire, Zero, Messerschmitt, historically almost every single engine propeller aircraft was built this way. But today, in this video, we're going to explore another configuration, one with its own distinct advantages and disadvantages, mounting the engine in the middle of the plane. Despite almost universal adoption, mounting the engine conventionally, i.e. in front of the pilot, has some key drawbacks. Firstly, having a massive engine in front of you makes landing and taking off quite difficult. A standard tail dragger will need to pitch the nose up considerably to have all three wheels on the ground, and this really limits the forward vision of the pilot. On a runway, you can almost zigzag a bit to see forwards, but on an aircraft carrier this is not so practical. Of course, you can solve this by going for a tricycle landing gear configuration, with one wheel at the front and one in each wing, like in the P-38 or B-25. But with the engine up front, there is no space for the front wheel to actually retract into, so you're out of luck. This lack of space in the nose is also annoying for shooting accurately. Ideally, you have all your biggest guns mounted in the center line of your plane, facing forwards. But with the engine in the front, you're often forced to mount them in the wings, angled slightly inwards so that they actually hit what you want them to, but only at a specified distance, say 500 meters in front, before they fly uselessly away. Another issue is that engines are often the widest component in the airframe, meaning that the nose of the plane is usually quite large, maybe with a big radiator on its chin like the P-40. This large frontal area produces drag, which is even worse on stubby radial designs like the P-43. Engines are also heavy. This means that your center of gravity can be quite far forward, which can make the aircraft less maneuverable. Like being on a seesaw with someone a lot larger than you, you need to exert a lot more force to make the beam rotate, or in this case, make the plane pitch up or down. So in the late 1930s, designers started to wonder, what if we move the engine backwards, behind the pilot? Naturally, the engine would still need to be connected to the propeller, but even in the 30s, this was relatively simple. The drive shaft would extend out of the engine, under the pilot, and into the reduction gear at the front, which would transfer all the power into the propeller. This freed up a lot of space in the nose, which could be used for guns, ammunition, landing gear, or in the case of the Bell P-39 era Cobra, all three. The P-39 is a great example of this configuration, and it shows that it worked, with almost 10,000 P-39s produced. This aircraft was designed as a high-speed bomber interceptor, and thanks to the mid-mounted engine, the P-39 could mount a 37mm cannon in the nose, firing straight through the propeller. This would completely obliterate a bomber. Most tanks at the time didn't even have a 37mm, never mind aircraft. The P-39's nose was so spacious that it could mount the 37mm cannon with 30 rounds of ammunition, twin Browning 50 caliber machine guns with 200 rounds each, a battery, oxygen tank, glycol tank, data case, and an entire landing gear leg, allowing the aircraft to use that stable tricycle landing gear. The landing gear was great, but the nose itself was also sleek and aerodynamic, giving the pilot an excellent field of view while reducing drag considerably. The P-39 used a nearly identical engine to its conventional cousin, the P-40 Warhawk, and you can see how much of a difference this made in terms of frontal area and drag. All the space at the front for guns and landing gear is great, but you still have to put the engine somewhere. What you're actually doing is taking space from your fuel supply. Many planes have fuel tanks in the fuselage, either between the engine and pilot or behind the pilot. But the P-39 was forced to store all its fuel in the wings, severely limiting capacity. This meant it was a very short-range aircraft. And while the 3-meter-long drive shaft was mechanically possible, the fact that the drive shaft, engine, and propeller needed to be secured to the fuselage over such a long distance meant that this entire length had to be strengthened to cope with the engine's torque rather than just the nose, which added weight and complexity. The engine position itself was also a bit awkward, especially during maintenance. Yes, you could stand on the wing and do repairs, but accessing the sides and bottom, or the drive shaft, was a bit more complicated. It also meant that, unlike something like a Spitfire or a 109 or a Mustang, adding a much larger, more powerful engine was a complex problem. You couldn't simply bolt it onto the front, you had to rebuild the entire fuselage. Also, while the P-39 was able to mount a 37mm cannon in the nose, it most likely shouldn't have. This gun was way overkill, and a 15 or 20mm cannon would have been much more effective. Higher rate of fire, higher velocity, more ammunition, less bulky. And 20mm cannons, if you so desire, can be mounted through the middle of a front-mounted engine with relative ease, like on the Bf-109, Yak-9 or MS-406. You don't necessarily need a mid-engined aircraft if you want to fire a cannon through a propeller spinner, a reasonably sized one anyway. And yes, the P-39 had a lovely, sleek nose with great vision, but the radiators, intakes and exhausts we see in the P-40 had to go somewhere, and they ended up producing more drag in other areas of the aircraft, the wing roots, under the belly, and above the engine itself. The pilot needed to be raised above the drive shaft, and his high canopy was another source of drag for the P-39. But despite these issues, the mid-engine configuration continued to be experimented with. The P-63 was a massively improved P-39, and the P-75 was a much larger aircraft with 2 engines, 2 propellers, and 2 drive shafts. There was even an attempt to create a mid-engine P-51 mounting the Rolls-Royce Griffin, but in the end, the mid-engine fighter was very rarely worth the drawbacks. Until, of course, the jet engine arrived, and suddenly almost every fighter aircraft had their engines mounted right in the middle of the airframe, enjoying many advantages first seen on pioneering aircraft like the P-39. Cannons in the nose, tricycle landing gear, good visibility. Their new power plants also meant they had managed to avoid many of the downsides that had plagued earlier designs. So next time you see an F-16, just remember the humble P-39 and the maniacs at Bell Aircraft that built 10,000 of them. That's the thing about suboptimal solutions. They have a habit of pointing the way. Engineering solutions to problems like this are what this channel is all about. I'd encourage you to subscribe down below and get caught up on my other content if you enjoyed this one. If you really enjoyed and want to support me further during this AI slop siege of YouTube, my Patreon is linked down below. Early access, ad-free videos, and a very luxurious Discord server, as well as exclusive content like this or this, all for the price of a coffee. Thanks again to all my existing Patreon supporters, and I'll see you all next time.